Hello! Today you will learn how to find a cross product, how to identify similar figures, and how to use a cross product to find a missing side length on a similar figure. So first of all, let's start with cross products. A cross product, we have an equation 3 over x equals 6 over 20. So the rule is you take the two numbers that are diagonal from each other, you times them. So we're going to take this 3 and times it by that 20. Then I take the other number and I divide it. Divided by 6. And that's it. Okay, the two numbers that are diagonal from each other, times them. Take the other number and divide it. And that is a cross product. And the answer, when I type 3 times 20 divided by 6 into my calculator, is 10. And ignore the bad text writing, but I think you understand the process. Okay, next one. Again, you're going to take the two numbers that are diagonal from each other. So in this case, these two are diagonal. And then we're going to divide by the other number. So I have, oh, that is going to be too light. I have 4 times 5 divided by 18. Now, 4 times 5 is 20. 20 divided by 18 is 1.11. Or I could leave it as 20/18 and just reduce that fraction down to 10/9. So 1.11 for decimal, 10/9 for fraction. As we go more and more towards algebra, this fraction answer is going to be better, which doesn't negate the value of the decimal answer. Okay, third one, cross product. We're taking the two numbers that are diagonal. Those are our two numbers that are diagonal. We're going to times those. We're going to divide by that third number. So I'm going to do 3 times 12, and then divide that by 5. Take my calculator, I type in 3 times 12 divided by 5, and I get 7.2. Cross products. Now, let's talk scale factor. If we have two shapes, and we made one shape bigger than the other, then we can look for the scale factor. Sometimes you can just spot it by looking at it. Sometimes you need to do a calculation. So right here, I looked here. This is 3. That's 6. 4, 8, 4.59, 3.57. What's going to be the relationship between these? Go ahead and insert a table. Maybe if it'll let me insert a table. Okay. Once I have that table in, I'm going to be like, hey, look, I've got the shape on the left, and it's got a 7 that matches up with a 3.5. I got a 6 that matches up with a 3. I got a 9 that matches up with a 4.5. And I got 8 that matches up with a 4. What's the relationship between these two columns? Well, I notice that this column times 2 is this column. Or this column divided by 2 is this column. So I would then say the scale factor from the big to the small is 1/2. And from the small to the big is 2. I could also do that by dividing. 7 divided by 3.5, 6 divided by 3, 9 divided by 4.5, 8 divided by 4. And pay attention to which way it's asking you to go when it's talking about scale factor. Is it going from big to small, or is it going from small to big? Because it can go both ways. So you're going to want to watch with scale factor which way you're going. The scale factor is another word for constant of proportionality or unit rate. It's all the same thing. Okay. Similar figures are proportional shapes. You will see them a lot on phones. If you have a phone and you zoom in or out, as you are zooming in and out, you want it to say the same proportions. You don't want to zoom this way because that makes your picture look weird. So when you're zooming in and out, you are actually creating similar figures. It's staying proportional and it's just getting bigger or smaller. So you might be like, I really want to see what's on the astronaut's face, and zoom in. When you zoom in like that, you are finding a similar figure. That is what similar figures are. So, in order to do a similar figure, we're going to want to find the missing side length on a similar figure. We want to find that length right there. Well, so it happens that you can find these side lengths by doing a cross product. So we can take, we've got this missing blue circle, I'm going to call that X, and then, so we can get it a fraction, there we go. I'm going to put in X there, and then I'm going to pick any other number. It doesn't really matter on this one because they've all got numbers. So I'm going to choose 8 on the same triangle. Okay, having chosen 8 on the same triangle, I'm going to look at that other triangle and try and find the other equation that needs to go there. So I'm going to, oops, sorry, I clicked the wrong button. Having found that other angle, I'm going to pick the ones that line up with it. So in the same position as the X, right here with the X, is a 9. So I'm going to put the 9 here. And in the same position as the 8 is a 12. So I'm going to put the 12 there. At that point, I have found a cross product. Now we know how to do cross products. We just went over how to do that. So I'm going to go ahead and do a cross product. Two numbers that are diagonal get times. So I'm going to do 8 times 9. The other number gets divided by 12. 8 times 9 is 72. 72 divided by 12 is 6. Or I can just throw that whole thing in my calculator. That's how it's done. Another example. How tall is the random guy? Again, I'm going to set up a cross product. Whenever you're doing similar figures, you want to set up a cross product. So on this one, I've got the big tree is 25, and the big length is 20. So I'm going to put those two in the same side. Now, the 25 lines up with the height of the guy. So the H has got to go on top. Very important to get them lined up correctly. The 20 lines up with the 5. So the 5 goes on bottom because the 20 is on bottom. Now I could put the 20 on top, but if I put the 20 on top, I have to put the 5 on top. Take the two numbers that are diagonal from each other times them, divide by the other number. 25 times 5 divided by 20 gives me 6.25, meaning the little guy is 6.25 feet tall. It's a pretty tall dude. Okay. How deep is the water? 31.5 feet from the shore. So I'm going to start wherever I want. I'm going to start with the variable this time. I'm going to put the variable. Well, the variable is part of the big triangle. So if it's the big triangle, I use the big triangle's number, and I'm going to do D and 31.5. Now, the D lines up with the same as the 2. You got this here, you got this here. They line up. So the D is on top, therefore the 2 has to be on top. And the 31.5 is along the side, which means the 6 is along the side, and the 6 has to be in straight with the 31.5. Take the two numbers, times the diagonal ones, divide by the other number, and that will give us our answer. So I'm going to type into my calculator 31.5 times 2 divided by 6, and I get 10.5 feet. Okay? A story problem. The Gateway Arch in St. Louis, Missouri is 630 feet tall. A 12-foot pole is near the arch that casts a 5-foot shadow. How long is the arch's shadow? This is actually, similar figures, is actually how they used to calculate heights of trees and stuff back in the day. So right here, we've got the Gateway Arch is 630 feet tall. We know that's the height of the arch, and we know that the pool is 12 feet tall. Now, the shadow of the pool is 5 feet, so that's going to be the shadow of the pool. We don't know how long the arch's shadow is. So this one represents the arch, this one represents the pole, times and divide. 630 times 5 divided by 12. 630 times 5 divided by 12 is 262.5 feet. That is a very long shadow. Okay. You got this. That's how you do similar figures. We believe in you.